Question 4. This question is from topic quadratic equations. Here in this question we have a straight line whose equation is given as y equals to 2x minus 5, and we have a quadratic curve whose equation is given as y equals to x square plus kx plus 1, where k is an unknown constant. They have asked us to find the values of k if the straight line cuts the curve in two distinct points. Though it's not required to draw anything to solve this question, but let me draw it to have a better understanding of the problem. Here I have roughly sketched a quadratic curve and a straight line where the line cuts at two different points. At first we need to write a new equation equating the quadratic equation and the equation of the straight line. Then we need to express that new equation in the form of ax squared plus bx plus c equals to 0. As the line cuts in two distinct points, we can say that the value of the discriminant of this equation, that is b square minus 4ac, must be greater than 0. And now, solving this inequality, we can find the range of the values of k. So let's begin. Now, by equating the two equations, we can write x squared plus kx plus 11 equals to 2x minus 5. So in the next line we can write x squared plus kx minus 2x plus 11 plus 5 equals to 0. So let's continue. We can write here x squared plus k minus 2 times x, and 11 plus 5 is 16. So let's plus 16 equals to 0. So we have expressed that equation in the form of ax squared plus bx plus c equals to 0. Since the line cuts the curve at two different points, we can write b squared minus 4ac greater than 0. Here for our equation, a is 1, b is k minus 2, and c is 16. Let's use those values to write in the next line k minus 2 whole squared minus 4 times 1 times 16 greater than 0. Now 4 times 16 is 64, so we can write k minus 2 whole squared minus 64 greater than 0. 64 is 8 squared, so here we can write k minus 2 whole squared minus 8 squared greater than 0. Now using the formula a squared minus b squared equals to a plus b times a minus b, we can write k minus 2 plus 8 times k minus 2 minus 8 greater than 0, which can be written as k plus 6 times k minus 10 greater than 0. Now we have another quadratic inequality of variable k, where the line will intersect the curve at k equals to minus 6 and at k equals to 10. So let's sketch here. On the left intersecting point it will be minus 6. On the right intersecting point it will be 10. Let's shade this part which is positive around 10. So let's shade the positive part here. This part is positive around value 10, and it will become positive when k greater than 10. Now at minus 6, let's identify the positive part of the curve here. So the curve becomes positive when the value of k becomes less than minus 6. So we can write k less than minus 6. So combining these two, we can write the values of k are k less than minus 6 or k greater than 10. So these are the values of k for which the line y equals to 2x minus 5 cuts the curve y equals to x square plus kx plus 11. So we have solved this problem, Now let's go to the next one.